Hi everyone. Today I'm going to be talking about the climate of India. So India sits at about 30 degrees north latitude at the convergence of the Hadley and Farrell circulation cells. It also is at the convergence of the trade winds and the westerlies, and that creates a subtropical jet stream. And the jet stream creates the monsoon seasons throughout India and Southeast Asia. The summer monsoon season is from about April to September as warm air blows from the southwest to the northeast, carrying with it precipitation from the Indian Ocean. During this time, there's heavy and constant rainfall that refills the aquifers, raises the water table, and also is very important for the hydroelectric power plants. Obviously, they bring electricity throughout the country and thrive during the monsoon season. The winter monsoon season is from about October to April, and it's a dry part of the year where the country experiences drought. The winds are blowing from the northeast to the southwest, so they blow over Asia and they don't bring any rain with them. I wanted to first look at the change in precipitation during the summer and winter monsoon seasons in India. Unsurprisingly, in the figure over here, January is still a dry time during the winter with no change in precipitation because they didn't get precipitation during this time to begin with. So that was kind of expected. Um, as visible in the figure, the June figure, there's an expected increase in precipitation levels during the rainy season. An interesting projection in figure 2 is the increase in precipitation along the east coast, the west coast, excuse me, but a decrease in precipitation along the east coast. So I'm not exactly sure why that is, but it is something to take note of. An aspect of precipitation that's not visible from these particular figures is the timing in which the rains begin and end during the seasons. So the position and strength of the subtropical jet stream will cause yearly variations. And since India is prepared for a specific monsoon season, variation in the cycle and precipitation levels have already caused some destruction throughout the country and will cause a lot more in the future. Because India sits along the coastline, the country is also at a great risk of sea level rise. The graph projected over the next 5 years shows an upward trend of global sea level change. Um, while ice melt is a large player in sea level rise, near India, climate change also changes the strength and pattern of the wind. So the westerlies that are a part of the Indian Ocean Walker cell are expected to strengthen during the summer monsoon season, and that causes sea levels to rise in the Bay of Bengal, and that floods the eastern coast of India. I included just two big cities on the East Coast. There are countless more with millions of more people in them that will be affected by sea level rise, and that's just the East Coast. So on the West Coast, the city of Mumbai has a population of 12.5 million people. And I did not code this or plot this, but I got it from a New York Times article, and it shows how much of Mumbai is expected to be underwater in 2050. So that is millions of people just in this one city that will be displaced. But there are also huge cities along the coast all around India. So there is a lot of people who will be affected. The next thing I wanted to look at was near surface air temperature and how that relates to the humidity and wet bulb temperature. So from these two figures, you can see that there's going to be about, or there's expected to be about a 5-degree increase by 2096. These figures look similar, but the values on the color bar are different. So humidity levels are expected to increase from 65% to 100% throughout the majority of India in January. As you can see, particularly the East Coast is expected to have extreme humidity levels. The wet bulb temperature measures the quantity of water vapor the atmosphere can hold, and it depends on the air temperature and humidity levels of an area. And it also has very big health implications for humans. So when the wet bulb temperature is above 35 degrees Celsius, latent heat cooling through sweating is no longer an effective way for humans to maintain their body temperature. So based on the humidity and near surface air temperature from the above figures, the wet bulb temperature in India in January of 2006 was about 28 degrees Celsius. And in 2096, the wet bulb temperature is expected to be about 36 degrees Celsius. So this high wet bulb temperature will cause enormous health risks for residents of India who are outside for extended periods of time or can't afford amenities such as air conditioning or clean water. So between sea level rise, precipitation variations, the wet bulb temperature, and correlations between epidemics and climate change, particularly in India because of the clean water, drinking water inequality, India will have not only a huge population displaced, but a large quantity of people are likely to die. However, unlike other areas around the world, India is in a position to change the future for themselves and the rest of us. They're the third largest contributor to greenhouse gas emissions. So if the country adheres to the plan as a part of the Paris Agreement, there's an opportunity to change the narrative of inevitable destruction and avoids the 6-degree temperature rise that's expected over the next 100 years. So thank you for listening.